All right, so this should be the second video you're watching for today. I wanted you to watch the first one where there's a woman talking and she's drawing a little house and she's doing that video of projectile motion. So I want you to watch that one first before you do this one. This problem right here is one that we had in our packet. So a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at a maximum height. The rocket's height above the surface of the lake is given by this quadratic equation. All right, I drew a little hill, I drew a little lake. So our rocket is going to follow the path of a parabola, right? Oh, and then they'll come down in the lake. All right, so basically, what is the height of the rocket after 1.5 seconds? So when we're solving that, we're just going to plug 1.5 in for t. So remember I think, in the first video they showed you like 80 is your y-intercept, but it's the initial height. So that rocket initially is 80 feet above the water. So it's taking off from that height. T is going to be the number, the time that the rocket is in the air. So at T0, it's sitting there at 80 feet above the lake. At T1, it's going to start going up higher and higher. So what we're going to do is plug in our seconds in for t, and that'll tell us what the height is at those seconds. Okay, so at 1.5, we plug it in. We get negative 16 times 1.5 squared plus 64 times 1.5 plus 80. So when we do that, we end up with 1.5 squared is 2.25. So we have negative 16 times 2.25 plus 96, right? 64 times 1.5 is 96 plus 80. And we end up with negative 36. So negative 16 times 2.25 is negative 36. So when we add all that together, we end up with 140. So the rocket, after 1.5 seconds, so it takes off after 1.5 seconds, it's 140 feet into the air. Okay. So now they're saying, okay, what is the maximum height reached by the rocket? So remember, to find the maximum height, we're going to use axis of symmetry. So when we do axis of symmetry, that's where we use that formula, negative b over 2a. So in this case, our b is 64 and our a is negative 16. So we're going to plug that in. So we get negative times 64 over 2 times negative 16. When we do that, we get negative 64 over negative 32. Negative 64 divided by negative 32 just gives us 2. So it reaches its maximum height after 2 seconds. So now what we're going to do is same thing as what we just did up above. We go h times 2. We put 2 in for t, and we solve our equation out, right? So negative 16 times 2 squared plus 64 times 2 plus 80. So when we plug that in, we end up with 2 squared becomes 4. So we get negative 16 times 4 plus 128 plus 80. And for this, when we plug it in, we get negative 64, right? Negative 16 times 4 is negative 64 plus 128 plus 80. So we end up with 144. So that means all the way up here where it has that turning point, it's at 144 feet, okay, above the water. So that's where our vertex is. How long will it take for the rocket to hit 128 feet? So now they're asking for, okay, we hit after 1.5 seconds. They wanted to know after how many seconds, what height am I at? So we put that in. We just plugged the 1.5 in for t. But now they're saying, okay, hey, what if I want to know how many seconds does it take me to get to 128 feet? Right? So this is going to be a little bit of a different setup. So now we just put the 128 in over here because remember, h is representing the height. H of whatever that t is the number of seconds. So for 128 feet, we put it over here. And again, this was covered in that last that last video, but I just wanted to do another one just to make sure we got it. I'm going to subtract 128 from both sides. I end up with negative 16t squared plus 64t minus 48. And we get, we're going to pull out our greatest common factor. So we pull out negative 16. That changes the sign on everything on the inside. And then if we had to factor this, if we use the AC method, what two factors multiply to a positive 3 but add to a negative 4? So when we do that, we get negative 16 times t minus 3 times t minus 1. Okay, and then what we have to do at this point is, okay, we do that t chart, and we go, okay, t minus 3 equal to 0 is t is equal to 3. And then t minus 1 equal to 0, and t equal to 1. So at 1 second and 3 seconds, it'll be at 128 feet. At 1 second, the rocket is still going up. It hasn't hit the vertex yet. And at 3 seconds, the rocket is coming down, but it hits 128 feet again, right? Because the vertex we found was at 2 seconds and it reached 144. So, we're going to have two points there, right? Could be 128 at 1 second and 128 at 3 seconds. And then they want to know, okay, how long did this total journey take, right? To go all the way from the top of the hill at 80 feet all the way down to 0 feet where it crashes into the lake. So how many seconds will will take the rocket to hit the lake? So again, we're looking for our roots are x-intercept. So this is just, we're going to have it just set to equal to 0, right? This one, we wanted to find what height it was when it was 128 feet. Here, we want to find out when it hits the lake. The lake is at 0 feet, so the equation is set equal to 0. We're going to find our x-intercept. All right. Oop. Let's see what's going on there. All right. Tell you, this stuff is never as easy as you think. Okay, here we go. So looks like for some reason it's there twice. Just delete them. Okay. So let me see. All right. So basically, we pulled out our greatest common factor, negative 16. We're left with, on the inside of the parentheses, t squared minus 4t minus 5. All right, because remember, this one up here, we had to subtract to get it to 0 and then solve it. This one is already at 0, so we got a positive 80. So in this one, it says what multiplies to negative 5? What two factors multiply to negative 5 but add up to negative 4? So we know, because it's negative here, when we multiply it, we're going to have opposite signs. And we know here that the larger one is going to be negative. So the two factors would be t minus 5, t plus 1. Because if I go negative 5 times positive 1, I get a negative 5. Negative 5 plus 1, I get a negative 4. All right. And again, what we're going to do here is, if we do one of those t charts, we can draw this out just like this. We get t minus 5 equal to 0. And it's just going to be t is equal to 5. And then t plus 1 is equal to 0. So when t is negative 1, it's at 0 also. So this is the only one, when you come to time, this is the only answer that you're going to use. Because this one, while the parabola crosses the x-intercept at negative 1, you can't have negative 1 for time. Okay. So before I show you the student problem, I just wanted to show you Desmos real quick. So this is our equation right here, negative 16t squared plus 64t plus 80. You guys can set this up in Desmos really easy. If I go here, negative 16, just make sure I got the right 64 and 80. Yep, got the right one. All right, good. So I put a little rocket there, right? I'm at C. It wouldn't let me use T, but it has me using C. So the rocket is at 80 to start. because t is 0. When t is 0, I have 80 feet. And now I can just sort of take it and have a rocket go. Right? It goes up. Oh, looks like I missed the vertex. All right. So you'll see it hit the vertex right there. 2 seconds, 144. And now it's going to fall back into the water, right? The water is going to be all the way here. So if I keep going, whoop, went a little bit too fast. It comes down and it hits it right there, right? All right. So if you wanted to set this up in Desmos, you don't have to do this first. These first two parts you don't have to do. The main thing, right? So let me just X out of this. So if I have that equation, all I have to do is just go, okay, don't put the f of x in, just go negative 16x squared plus 64x plus 80. All right. So that shows you the parabola. But the thing is, we want to have that slider that I was able to move things around. So just change your variable from x. Let's change it to t. This will make that second problem going to be really easy if you can do this on Desmos. It says add slider for t. I'm going to press that. And now I can answer any of those questions, right? I can basically slide along. This is going to change my t value. So at 0, I know what it is. I can go all the way up to, I can see where I end up having a, if I'm looking at this, where does that equal 0, right? So it equals 0 at 5 seconds. And again, you can even just go up to here and go, okay, there's the vertex. Let me just click at the very top. Tells me 2 seconds, I'm at 144. So you can do that with your problem that we're going to go to right now, okay? So try to use Desmos. If you can't, use a graphing calculator. All right, so let's go back to that. So your problem is going to be this one right here. You're going to answer the questions in Edpuzzle. It's on a 15-story building, which works out to be 160 feet. So you're going to answer these questions, and then we'll have an exit ticket. All right.